Hello, everyone, and welcome to the Impractical Machinist Podcast. My name is Patrick, and you can find me on Instagram at JobShopperTN.
I'm Cameron from Machining is Cool.
I'm Bradley with Marvel Machining.
On this episode, we're going to continue answering some questions we got through our Instagram questionnaire a few weeks ago. Let's get started, boys. Work's been, sporadic, and up and down, but we've had some good stuff happen this week. Got some good prospective jobs going up.
Has it been slow for you guys too, Cam?
No, it slowed down a little bit. I'd say about 2 months ago, maybe 3. POs started coming in a little bit less, or RFQs. But we're still busier than we can maintain. It's always a constant game of you catch up, and then something happens, and then you fall back behind a little bit, and then you catch up again, then you fall back behind. So right now we're in the transition from being fallen behind to being caught up. So, and then it's about to go to shit because we're about to get a machine, and you got 2 machines are getting moved. So we're gonna pull the coolant tanks out and clean those out, get them ready to get moved, pull the power off of them, clean the tank for the machine that we're selling, pull the power off of it, riggers, the whole 9. So we're probably gonna have an entire week where we're not really getting anything done. So right about the time we're getting back to a good spot, it'll go to shit again.
Yeah. I just finally caught up from being gone for a week at IMTS.
Really?
But
I
just finished a job. I got it out today down to finishing early, and it was like 2 o'clock. I'm like, I'm done for the day. I shut everything off.
Yeah. Yep. That own boss life.
Yeah. Right. Yeah, I had a job that kicked my ass. Was it last week? I think I shared a little bit where I made the mistake. Finally caught me programming and leaving, and I didn't simulate. I was in a hurry, and I just trusted it, posted it, and left.
Always simulate,
but
get you. It's always usually if I don't simulate, what gets me is something that would have been painfully obvious had I simulated.
Oh yeah, and that's what got me. It was just my line segment. When you program, you can pick the side of the line that it's going to cut on. It cut on the wrong side, and I've noticed it more so with the most recent update. It's been defaulting to the wrong side, and I've caught it a couple times, and this time I didn't simulate, and I know there were 4 features that were the same, and I looked at the other 2. I just glanced at them. I knew they were on the right side, so I just posted, threw it in the machine, hit cycle start, left for the day, came back and saw a big gouge in the part. I'm like, God damn it, that sucks.
Were you able to save that?
They ended up accepting the part as is.
Okay.
It didn't affect any function of the part. It just had a nasty gouge in it.
Well, that's good.
So, but I mean, I had 45 hours in the machine in that part.
Wow.
Is that all between programming and running?
That was just machine time.
Geez. Holy moly.
Yeah. I bet you were shitting bricks when you saw that.
Yep. I was pissed.
Yep.
I came home from practice in the evening. I opened the doors. I saw it, and I'm like, I'm just going to close the doors, shut the machine off, and go in the house for the night.
Yeah. How much was that material?
It was like $600. It wasn't bad.
Yeah. Still sucks.
Yeah.
Yeah. At least you can get stuff like that the next day. Usually, they're like the same day, whatever. It seems like you always get shit right away.
Yeah, I had it ready. I had already reached out to them.
Yeah.
They were trying to figure out if they were going to accept it or not, and they were ready to cut it. I would have had it next day, and I would have ran the part all weekend.
Yeah.
So.
Yeah. What really sucks is when you kill some material, it takes a while to get, like burnouts or something. We do a lot of A36 burnouts, and it seems like it. Even if you can get them to rush it, it's still going to be at least a week.
Yep. Yeah, the parts I actually finished today, they were stainless. My supplier cut it short. They shorted me like a 1/4 inch on one of the cuts, so it wouldn't even clean up. And I reached out to them. I caught it, and they didn't stock that material. They sourced it somewhere, so they had to source it again. So I had to wait like 4 days to get it.
Yeah.
Oh, wow.
A pain in the ass.
Yep. First world probs.
Right.
Yeah.
I'd wait 4 days for material. Yeah. That's Minnesota problems. It seems like you can get everything you need right away.
Oh, yeah. Yeah, we got one big supplier that You can order it online. I email them all the time, but they do a same day cut, and it's just like a $45 fee.
Yeah.
Typically, they'll cut anything for you same
Hell,
day.
I mean, at that point, why bother keeping anything on a shelf?
Right? I don't keep anything on the shelf.
Yeah.
And that one, they got a customer center. You can walk in and you can pull 12-foot bars off the shelf yourself.
Yeah.
And they're all tagged. They scan it, give you a cert for it.
That's
so.
cool.
Nice.
Yeah, it'd be nice to have something like that.
So on that note, okay, you mentioned certs. Let me tell you a little funny story before we get to the question. So our manual machinist and the owner have been working on building a couple of weld fixtures for the fab shop. And they always like building stuff like that from just like scraps that we have laying around, which we have a ton of. You know, I've said it before, owner's old school. He don't throw anything away. But we didn't have anything on hand that he could make this one, a few parts out of. It was a pretty big chunk of steel that he needed. So he went down to Athens, Tennessee. So the owner goes down to Athens, which is like 20 minutes away. There's a place there where you can get, whatever metal they have. They have drops and just junk, and they do have some bars and stuff. And he gets this big chunk, and it's like a 125-pound piece of, I don't know, it's probably like 5 by 5, like 15, 16 inches long. I mean, it's a big chunk. So he gets it for dirt cheap. He brings it up here, and then he's gone for a few days. So the other manual guy starts cutting on it. And he intended to buy mild steel, whatever, 1018, A36, whatever. Well, he starts cutting on it, and he gets a bunch of gray dust everywhere, and he doesn't get any color in the chips. What does that mean?
Little cast
Piece
iron.
of cast iron. Exactly. So, which worked fine. I mean, for a weld fixture for our use, but
yeah, I was gonna say for a weld fixture that might be kind of nice.
Mm-hmm.
I figure weld splatter and stuff isn't gonna stick as well.
It probably not. Yeah. So
I've tried to weld cast iron, and I know the welds don't stick. So.
Yeah. So it's just kind of funny. Now the other side of it is some of the parts, like he surface ground quite a few surfaces on it just because that's what he does. You can actually see quite a few cracks in it, and that was surprising. We want to get started on questions, boys?
Sure.
All right. So
yep.
This first one,
what do you got?
Is from a very, very good friend of ours, Kenny Urban, otherwise known as Patriot Machinist on Instagram.
The only machinist that can't spell machinist?
Yeah, exactly.
No, there's no way he's the only one.
Yeah, that's true.
So Kenny asked us about program management. And do you save programs in case of a repeat job? So I'm curious how you guys do it, because we have a certain way of doing it.
I save my CAM files. I just keep everything. I don't save the NC files. So when I'm done programming, I mean, sometimes I go back and forth adjusting feeds and speeds on the machine. I'll adjust the dials or whatever, and when I'll go back to the CAM system, adjust it, and typically when I'm done with it, I lock all my operations so they can't be adjusted from there, and then I save the file. So when I come back, it's just post and go, and I know that it was. When I lock them, I consider that proving out the program.
Right. Mm-hmm.
So,
okay.
I usually put notes in there, so it makes it easy to see if there's anything in the program that I need to watch for, or set up different tool lengths, stick out of holders, everything I would throw in there.
Yeah,
nice.
The way we do it is, I mean, I think if I was working by myself, I would definitely do it your way. And honestly, there's parts that I think I'm probably the only one that's ran them, because whatever. If I am the only one that's running it, and I know it's probably not going to come back, that job's probably not going to come back, or I know if it comes back, I'm probably going to be running it again, I won't bother with the setup sheet or anything. I'll just go and do it and run through it. And then if it comes back, I'll do the same thing as you, pull up the CAM file, check it out real quick, and post it and go. But typically what we do is have printed out setup sheets with folders, the job folders like everybody uses from Uline, the clear ones. And so we got a filing cabinet, keep everything sorted by part number. And whenever the job comes up, we just go grab all the setup sheets are in the one folder for that job or for that part. and then all the programs are on one USB card. And so whenever it comes back around, you just go grab that same exact program that was ran the last time. We know it's good. Same setup sheets. Setup sheets will have, tool numbers and stick outs and all that stuff. What holder, if it's a specific holder you need, it's on there. Setup notes, everything. So
And you throw a USB in each folder?
yeah, they're cheap. So
Yeah.
I think they end up being like $1 a piece or something off of Amazon. We don't do anything fancy.
Oh, wow.
Yeah.
Nice.
Yeah, I like to be able to open the cam file and simulate it and watch it again just to know exactly what's going on, refresh. Most time I remember, but...
No, and I do too. And what we'll do sometimes, so there's a computer on the shop floor. What is it called? Is it NC Viewer?
Yep. Or Simco, or
I think it's NC Viewer, where you just drag and drop your G code in there, and it shows you all your toolpath. So sometimes I'll throw it in there real quick on the shop floor computer while I'm out there, just to kind of double check what I got going on, and just do that. But
I don't know what other softwares have it, but CamWorks has it's called, I think it's shop floor automation, where you can throw it on a shop computer, but you can simulate, you can see all the tools, tool crib, tool list, holders. You can't edit anything. You can see the feeds and speeds, but you can repost it. So if you're on the floor, you can see everything like it was in the cam system, post it and go. No editing capability.
Yeah. I believe Fusion's got something like that too. I've played with it once. I couldn't really tell you what its capabilities are, but it's on their like the Fusion Team Viewer or whatever it is.
Yeah.
So it's all on the internet. Just log in.
I think that'd be a pretty nice feature if you got a big enough shop where guys are constantly posting programs or loading programs on their own.
Yeah. For us, it's usually you take your setup sheet and your card, you go do whatever the setup sheet says, and then you load your program and go. And most of the guys on the floor aren't, typically, I won't say all the time, because there's definitely plenty of times where, you post something, you think all the speeds and feeds are going to be good, step over is going to be good, and then it shits the bed on you. You got to change stuff. But usually I've got pretty dialed feeds and speeds, because the main thing we're running is mild steel most of the time. And we have standardized tools for it. So it's like I keep it all saved, same step overs, feeds and speeds. And then there's certain things that you just know aren't going to work or will work, like with long end mills and stuff. So a lot of the times stuff doesn't need adjusted. Now, if it's the first time running through, I know it's the first time, I kind of keep a mental tab on that. And so whenever they go to run it, I kind of have an ear out. And if something sounds like crap, I'll go out there and check it out and change it for them. Or if they come to me, I'll change it real quick. But then after that first part's ran, usually we don't have to touch that program again. We leave it the way it is. So you just, from there, you load it, run it, finish a job, mark the job done, move on to the next one. So, and then I keep a bin for each machine in the programming room. And so as I'm going through screening jobs, I'll take that job folder, go find the setup sheets, put them together, just kind of keep one in front of the other in separate folders, put it in the bin for that machine. And then as the guys, I'm like, hey, you're going to run the D&M 4500 today. Like, all right, cool. So they go run whatever's set up on it. After that one's done, they grab the next thing in front, pull that out. It's already, setup sheets are already there, program's there. They just go set it up, run it. Material is on a rack outside or on a rack in the saw room, and the last 5 of the PO numbers written on it. So they can just go grab their material, just match up numbers. You got your material, and then go, and it's easy. It's all kind of
I'd assume you got stock sizes on the setup sheet somewhere. What do you do if stock comes in and it's oversized or undersized? You adjust the program, or
I mean, when you're working with burnouts, it's going to happen. I guess depending on who's doing your burnouts, but there's definitely been plenty of times where it comes in and it's a little bit over. Now, if I know, obviously when I'm programming, I know what the material is going to be. I know what we're planning to use, and so I'll usually oversize my stock by 1/4 inch, just to have some give there in case when they burn it out, it's a little bit big. Or the kerf angles, it's got a big kerf angle on it. And so the end mill doesn't cut 100 thousandths at the bottom and 30 thousandths at the top. It'll just start from the outside and work its way in and start cutting when it gets there.
Yep. And then do you program off center part when you do that? So then when you're coming in, it doesn't make a difference.
Yeah. There's a lot of setups where we do Mighty Bite VersaGrip jaws with their heavy duty grippers. So and the heavy duty grippers are hardened, so they work great on the flame cut surfaces that are hard. And so it's 8-inch wide jaws. Set up your grippers however you need to. Throw your part in there. Pick up center, and then usually pick up the top of the jaw. Make that the Z0. And so I'll work off of there, and then I can go and cut. I know exactly how high I can go off the jaw and not touch the grippers. Usually I go like 230 off the top of the jaw, and that gets like right on top of them. I think they're like 210 or 220 tall.
Mm-hmm.
But yeah, so then you can cut as deep as you can. Usually we try to order the material oversized enough to where you can get a full profile around the part, and like finish the full profile of the part. So when you flip it, you don't have to blend anything. Yep. Sometimes though, it's not practical if it's really thick material or something, because it gets more expensive. But yeah, so that's typically how we roll: center, bottom, oversize it in the program.
I'll go a little deeper into like our whole like file management things. We use Dropbox for like all of our shop files. So when they quote it, the material quote goes in Dropbox. It'll be like your main Dropbox screen. Then you'll have a customer folder. You'll have a part, maybe an assembly folder after that. If it's a package of some kind, then you'll have a folder for the part. And then within that that folder, you've got like folder for the print, a folder for the solid, a folder for a folder for the program, folder for like a DXF if we're doing laser water jet work, whatever. So everything's kind of broken up into folders that way. Now, usually, I've actually just like in the last month or so, I've gotten in the habit of going ahead and posting out the NC code and saving it off as the notepad file from SolidCam and putting it in the same folder, because it actually is kind of handy to just be able to pull up File Explorer, go through Dropbox, find that, and then just copy it onto their flash drive instead of having to actually open the CAM file up, wait for it to load, and go through it. Now, I do, if it's a weird job, like a kind of an oddball job, not a repeat job, I will pull it up so they can see it, because I want them to have a little bit more comfort in, seeing the 3D simulation. And I mean, up until the last few months, I always would, because I didn't bother posting the code out beforehand. I would say we usually don't save programs on machines unless it is like either a repetitive thing or, I don't know, something that's like really tuned to that machine. Because I mean, all of our machines are different. They're all houses, but they all have different spindles, different travel, whatever. So, and there is a lot of hand editing I have to do on certain jobs, whether it's just for speed or if it's for just function. Like our gantry router, there's some really weird things you have to do on it at times that I'm sure I could work with SolidCam and get that to happen, but it honestly be more of a pain than it's worth. So
I only post out program one.
Mm-hmm.
My machines don't have any programs but program.
I
did
wondering.
I do the exact same thing. So
I can't stand having programs.
Me either. Well, we all all FANUC, and so you've got like 7 megabytes of storage on that thing. And so the way that everybody does it is we load everything as program one. So then after you load your program, you can go O1, O search, whatever. And then whenever you're done, you just do O1 delete, execute. Yep. So now your program's gone. You don't have extra shit stored in the memory. You go pull up your next, pull up the USB card again, import or, whatever. So load it as program one again, and then just revolve it out every single time.
We do similar on job shop work. Everything, and don't ask me why, everything's always 101 for mills, and then it's 1001 for lathes. Don't ask me why. That's how it was when I got here. But that does work, because I mean, you just overwrite the same thing every time. It's fine. But like on the DM2, we have 4 that do a lot of repetitive work. They probably have, the DM2's probably got 30 programs on it that just stay there, because I mean, they pretty much just switch one repetitive job to another. And then
the one thing that worries me about doing that, which I mean, obviously, if you're only going to run that same job on that machine all the time, like if you're only going to run that job on the same machine every single time, it doesn't matter. But like for us, I want everybody to stay in the habit of deleting that program as soon as you're done, and then uploading the new program. because otherwise, and like basically stay away from pulling that program off the machine, because at some point I'm going to need to run that job on something else. And I don't want like hand edits that have been done or speeds and feeds edits that have been done at the machine to be on that one program and not in the CAM software. So that way, when we move it over to another machine, all of a sudden you have a whole bunch of problems. It was running just fine before. I want to avoid that. But, and I mean, obviously, if you've got a repeat job that's always going to run on the same thing, then cool. We don't really do much of that.
Right. Yeah, it's a little different when you've got either like programs that will only ever run on one machine because that's the only machine you got to run it on, or that kind of thing. So, and that's where if there's a lot of edits, well, actually, what I try to do, emphasis on try, is anytime there's hand edits at all at the control, I back it up and I put it back in Dropbox. That way, if it were to get deleted somehow, by accident or whatever, I've got the right program with all the current edits and everything backed up, ready to just be copied over. So now, like I say, it doesn't always happen. Sometimes I might not be the one making the edit. If the operator does, they might not think, to bring me the USB with the program on it when they're done. If I do it, I generally back it up.
What kind of hand edits are you usually doing?
Well, I mean, it'll be anything from speeds and feeds to just one thing that one thing I've started doing, and this is something I could probably have like a post edit or a post edited to do. Like on the DM2, the VF4, they're fast enough that by the time the head goes from tool change heights to the part, the coolant on the way it's been posted out is on the G43 line. So the height offset call. And the tool's already there and it's cutting for like a second before the coolant even gets all in and swelling. Yep. So, that's like a minor thing that we have to do quite a bit on stuff that matters. But a lot of times it'll be like moving the table to a certain spot at the end of the cycle. I could go on for 30 minutes about crap I've got to edit for the router. I mean, it's crazy, but
yeah.
And even then,
can you add a pause? Can you add a pause into your coolant?
That's probably what I'll end up doing. Is what we've done at the machine is just put the M8 or M88 or M83 or whatever right after the tool change.
Yeah.
But you could do that. Just do G43 H whatever M8 and then a G4 P1 or P2 or something like that.
I think mine's on the same line as the spindle speed and direction. So right after the tool change, it's S7000 M3, then M7 or M8.
Mm-hmm. Yeah. So there's a lot more, and even then, it might just be editing something to work. If you have to tweak the drill depth, tap depth, speed, peck, whatever, just do it at the machine and back it up later. So
yeah. I guess it depends too on your confidence of people editing programs at machines.
Yeah, for the most part, I mean, it's usually me or the other programmer doing it. Our lathe guy will do some stuff. Actually, that right there is a big one. All of our lathes cut tapers to different degrees. And sometimes that's not just because the machine's a piece of junk. It's because it's a flimsy part. Most of the time, it's because the machine's a piece of junk. So, he's having to add in, U codes and stuff like that to try to adjust for taper, and it's not something I could picture doing in CAM unless like you just had a U line on every single Z move, and that's stupid.
Wait, you could sketch the taper to compensate.
You could, but it's just a lot simpler. Just
but then
U code.
Nope. That's what I'd do. I'd sketch something. Well, whatever you're talking about, the U stuff, that's just over my head.
Well, you're also you're also not a lathe guy, right?
I have never watched my lathe code. I don't even look at it. I just hope for the best when I run that thing. Post and go.
Yep.
I mean, I know what it's doing, so I watch it slowly. Mm-hmm. I usually will step through it just to make sure it does the right thing. Sometimes I'll back it off. I'll offset it like an inch or something just to make sure, but I don't look at that screen.
Yep.
I don't even want to try to learn turn-in code.
Well, I mean, quick little tangent. I mean, the other day, I think I showed you two. I was having to turn some shafts that were, let's see, 25 millimeter diameter by like 4.5 inches long. And Europeans, excuse me for mixing the two up. And I mean, I was actually having to, even though it was a straight diameter, I was having to add in Z moves to make it cut like, a weird bell shape. And I'm talking on the order of tenths, but just cutting a bell shape in order to actually make a straight shaft. And, that's just a pain. And also, I guess when you've got a guy that's waiting on you, it's a lot easier just to hit the buttons a few times at the machine, get him going, then actually go back to the computer.
Yeah,
make some edits,
I guess it depends on how far your walk is.
Right. Yeah, it might be 30, 40, 50 foot walk or whatever.
For me, my door's right outside. Well, it's like an open doorway from. I mean, there's literally two machines right outside the door, so. I was like, oh, let me go change it real quick. So I'm in the habit of, if there's anything that needs changed, I like to just go and do it in the program right then and there. That way I can't forget to go back and change it later.
Yeah.
And I can't fat finger something.
Right. And that, of course, that is one thing, like on the taper thing. I mean, it's different every time. I mean, I was actually having to change it. Like I had 10 parts to run and I had to change it, 3 or 4 times during the run. I mean, it's
Were you doing like pre-finish passes so you could check it as you go and then adjust right before the finish?
I was trying to. I actually ended up. I got so aggravated doing them. I would offset the tool up like 20 thousandths. The finish tool. I mean.
Oh yeah.
Let it run. Drop it 5. Drop it 5. Start checking it. Adjust it. Drop it 5. Check it again. And then usually I'd have 4 or 5 thousandths left to actually get it worked into size. Oh man. If you have a lathe that's like in good shape and the turret's lined up good and the spindle's in good shape and it's not been crashed crazy, they're great. But holy crap, if you have one that's been beat around and knocked and realigned 15 times and this and that, oh boy, it's a mess.
So what you're saying, I got lucky that I don't have taper in mine yet.
Yet. Just wait.
Because I'd probably just unplug it at that point.
You do like you did with a surface grinder.
Yep.
Oh man.
How difficult is it to realign the spindle on the Haas lathe?
We always have Haas come in and do it. I don't know. I know it costs about $4,000.
Jeez.
So it's usually for them to come in and do it. I mean, it's usually like a 5-6 hour process, and they come in. If they do it really thoroughly, I mean, that's all the way. Take the chuck off, put their fancy spindle master gauge on, get that lined up right, tweak the Z rails and X rails in to make them as square as I can. And then they start monkeying with the turret, trying to get it clocked right, flat, square, and straight, and all this. It's a mess.
Are there like mounting bolts for the spindle with jack screws to adjust it? I never messed with the Haas. That's how ours is. We've got a Johnford that's like that, and it's been crashed a handful of times. And honestly, sometimes it just works its way out of alignment just from the cutting force, and I think that's what happens anyway. It seems like it just slowly gets worse and worse. So like the turret alignment and the spindle alignment. So every now and then, usually it doesn't happen until there's a crash. Then we realign everything. But and I think I haven't done it myself. I've just kind of watched the guy that was there doing it after the last big crash, and he was just cutting a test bar. Just threw a piece of like 2-inch or 3-inch aluminum in there, 2-inch aluminum, and make a test cut. Just hand feed it, and then adjust the spindle alignment, and kept doing that until he had it dead on.
Yeah.
I got a question. Back to the program management. How do you guys save your files for the job? I got a customer folder, and then customers are separated. And then inside there, I've kind of gone 2 different ways with it. I haven't figured out which way I like yet, so it's kind of fucked up. But sometimes I'll save it by the part number. I'll have a folder with part number, then everything in there, or I'll do the PO number, which I don't really like because then I got to find the PO. Sometimes I like to reference back to the PO too.
Sure.
Yeah.
I would do part number. always.
Part number.
And I like to put in, I mean, on our travelers, it'll have like the part number, and then it might have a description. I mean, let's just say it's part number 123, the description is shaft. Sometimes I'll put part, the name of the folder will be part 123 dash shaft or something like that.
Do you put rev levels on the folder?
I do. It's very, very seldom that we ever have to deal with that, fortunately. But yeah, it's either, I think when that's mostly happened, they usually tell us, hey, switch to Rev D and get rid of everything else. So that's generally what we do is just delete, what we need to. That has bit us a couple times. That's actually where I really like how in Dropbox you can restore files that have been deleted. Because there was a time one of our quoters went in, he noticed they switched from Rev D, from Rev C to Rev D on a part. And it was one of these production parts we've been doing. And we didn't even know what changed. He didn't know what changed, but he just went ahead and scratched everything else away and put the new one in. Well, guess what? We lost our programs. We lost our solids, our drawings, everything. And, of course, we got it back. But, that was a mess.
Yeah. The way I usually do it is by customer and then by part number. And then underneath that part number folder, I'll keep prints, solid. I'll have a folder for prints, folder for solid models, folder for setup sheets, and a folder for inspection reports. And then under inspection reports, I'll have a folder by PO number. Okay. So then you can go into that inspection report folder, grab the PO number, and then see all the inspection reports from that job. So then whenever you're trying to search stuff, you can just search the part number, go right to it. And then you can also, I guess if you're making a repeat part a lot, you can go back and kind of track how well you've made it in the past. And be like, well, the last 7 times we made these, we've had that same dimension. We've gotten the same dimension whenever we check the part, or the same measurement. So I don't know what to tell you. You've accepted it every other time.
Yeah, another question you want to move on to?
Automating a shop and running with minimal versus hiring many employees. So I'm assuming running with minimal employees versus just hiring employees to run your parts for you or whatever. So,
well, we know someone that just recently kind of went down that road. Awesome Solutions just got him a little robot for his shop. And we know a fellow from California, a guy, he's got a couple components, I think, that he runs machines with. I asked him one time, I asked a guy, how long does it take, to set up your robot to run parts? Because to me, not really knowing much about robots, which, mind you, robots are probably the highest level of automation that we can talk about. But he said about 3 hours. And that blew my mind.
Per job?
Yeah, per setup, per job, whatever.
Damn.
Of course, he's running generally high quantity stuff. But he said, he'll set the robot up for 50 pieces because, sure, it takes you 3 hours to set up, but then it's going to run basically
all night
on its own. So you might get 8 free hours out of it. Now, I'm sure that could be easier. My only experience with a robot is the fab shop actually has a robot welder. And it's pretty cool. And I like the way that it works. It's basically like I don't know what you call it, but it's like a teachable robot. You basically hit a button, I don't know what the button is, but it's basically teach. You move the arm where you want it. You hit, another button that tells it start the welding arc, move it along the part, tell it stop, pull it away. So it does take some time if you got a part that has a lot of weld beads and stuff. But they set it up for 2 or 3 different jobs over at the fab shop that it just, it really smokes any kind of manual welding process.
Yeah.
Can you, I guess, Guy or Possum, anyone that's got one can comment. Can you save the robot's motions for the job? Can you put it in your program management folder? The robot moves this way, pull it up with the job, and it does the same thing every time.
I think it'd be really stupid not to be able to have, to have that feature.
Our robot welder, you can. So I'd say so.
I'm sure you can.
I think too, if I was, say I had a robot set up, say Possum set up, for example, he's got he's going to have a dedicated place for all his vices. He's going to load the material into the vices. And the robot is only loading the vice. So it's pretty much always the same motion for the robot. It's grabbing from whichever location, outside of the machine, and then going to whatever location inside the machine. I mean, if you've got like 0-point plates on your table and then 0-point on your fourth axis, you can have all those dedicated positions set up already if you can save your programs and say, all right, we're going to go from here to here. It's the same motion every single time. So you could program it all ahead of time. So then there's no implementation for the robot whenever you start a new job. All you have to do is set your stock in the vise wherever it needs to be in the vise and then load your program and you're ready to roll.
Yeah. I think the biggest thing is there's a lot of cost up front of that because you got the robot or cobot,
Right.
You got all the vices, all the 0-point stuff, all that.
But I mean, I think the way he did it was really smart, though. I mean, he bought a used one that was in good shape. He's able to get it in there, implement it for a fraction of what it would cost to hire an employee, and he can go ahead and implement it now as soon as he figures it out.
Just think, though, man, instead of buying that robot, he could have bought him like a slightly used truck.
Yeah.
Right, Brad.
Why would you buy a machine when you can buy a new truck?
Yes. There we go. That's Brad's meme.
That makes no sense to me.
But
you know how cool you look driving around in a new truck?
But at the same time, I mean, if you weigh all that upfront cost versus paying somebody $50,000, $60,000 a year or thereabouts, maybe even more, depending on where you are, plus taxes and benefits and all that other garbage. If a robot can help keep you from having to make that leap from like a one-man shop where you don't have to worry about all that junk to a two-man shop where now you're not making near as much money because you're paying all this extra overhead, it probably is worth it. And I think that's probably how Guy looks at it, I would say.
Yeah. That's obviously it's a case-by-case thing. It depends on, now this is coming from somebody who has no robot experience, but depending on...
You've never done it on a dance floor?
That's about the closest I've been to a robot. And it's a pretty shitty one at that. What kind of parts are you running? What quantity are you running? What's the setup in the machine? Are you doing a bunch of awkward parts that require in-depth fixturing? Or can pretty much everything you run go in a vise? So there's questions like that to be answered. Like for us, we're high mix, low volume. And a lot of awkward shaped parts or stuff that you would really need a decent sized robot, just due to the weight, you would need a decent sized robot to load. So to get our foot in the door with a robot that can handle the weight of the parts that we're machining is pretty expensive.
Mm-hmm.
You're gonna need a pretty powerful robot to do that.
I saw one at IMTS that could hold up a car.
Yeah, I saw that Corvette.
Yeah,
they make them for you.
They had that at IMTS in 2022 as well. They did the exact same car and everything. But you got somebody like Possum, for example. Pretty much, I would say almost everything he makes, and he's got his own product line. So you can have everything saved, your program's saved. I'm assuming the robot program's saved. So all you need to do is load the correct size material in a vise and pull up the program and hit go, and it makes your parts, right?
Mm-hmm.
And so whenever you have that scenario, that's probably ideal for a robot. Even if you're only going to run 10 parts, that's 10 parts you don't have to load. You just load up the material in the vise real quick and then press some buttons and it's on its way. As long as everything's proofed out, like as long as you have good systems and you don't have to do troubleshooting every single time you go to use the robot, then it should be pretty plug and play, I would think. When do you need to hire a machinist over hiring or buying a robot? For us, getting another machinist is going to be more impactful than getting a robot.
Yep.
Yeah. It just depends on your work. Because like if you're doing job shop work, a robot really ain't much help.
Unless you're a job shop that gets a lot of high volume orders,
Yeah. I mean, unless you do have a machine running production. I will say, I mean, one of the benefits to a robot though is just it can run all the time. Now, your machine has to be able to keep up with it, and your process has to be really dialed in for it to work, or you got to have some checks and balances to make sure stuff's not breaking, you're not making bad parts. But I mean, we were at risk of losing some pretty big work to a shop that had, so these production parts we've been making for a while now. We were making them across 2 machines at one point, 3 machines. We've been making them across 3 machines to try to keep up with volume. It's a Haas DM2, Haas VF4SS, and a Haas VF1. DM2's got a pallet changer. We were at risk of losing that work to a shop that had 1 VF4 and a robot.
Yep.
Fortunately, we didn't. And I think it might be a case where they're doing the volume's probably so high that they're doing some of it and we're doing some of it. Not sure, because they're 800 miles away. But so there is that.
Yeah. I mean,
I'll say my horizontal pallet pool has been pretty nice. I do high mix, low volume stuff too. It's nice to. I have it set up for 6 different setups, so none of my tombstones are the same. So I can set a part in tombstone 1, throw it in there, for quantity 2, let it run, and while that's running, I can load pallet 2 with something completely different, program it, let that go. I got 1 that's got a 3-jaw on it, so if I ever get anything round, I got that first one set up. I don't have to tear anything down. It's nice. It's I don't do much production, but I will say if I have done 1 or 2 production jobs, and it's been nice to be able to schedule 4 pallets and just walk away.
Now, so where are you at whenever it comes to like the first run of a part? Are you will you go and do your 2 or 3 different setups on 2 or 3 different pallets? They're all first time parts, so it's the first time running the program. You schedule all those jobs and just let them go. If your simulation looks right, do you trust all your feeds and speeds enough, or where are you at on that? Because I know you like to just load a program and hit the road.
I guess I haven't gotten that far with the horizontal yet, because usually most of my parts are low volume.
Yeah.
It's 1 or 2, so it doesn't really make sense for me to set up another pallet for second top. I'll usually just flip them in the same pallet.
Well, I'm saying have a whole new job on another pallet.
Yeah, I've done that, and I'll load it and walk away.
Yeah,
I trust it.
So it runs job 1.
I trust my program too
run
much.
Job 1, and then immediately after that, run job 2, and then run job 3.
Yep.
Are you doing tool breakage detection?
No.
Still?
I got a lot of faith in my program.
I don't know. There was that one time.
Yeah, there was that one time.
That's why I was wondering if you ever got around to messing with it.
No, I actually I took my tool setter out of my machine because I had a part that was too big for it and it was in the way.
Yeah.
When it swung around, it would hit it. So I took it out. I haven't put it back in yet.
Yeah, because you set your lengths all outside the machine, right?
Yep. I got a tool setter outside of the machine, and it's universal for all 3 of my machines.
That's nice.
That is pretty nice.
Then you can have your. I remember you seeing tool tags. Do you put the length on the tool tag?
Yeah. Yep.
Okay.
That's all I put on the tag.
So you just leave it set up. Well, yeah. I mean, you can just look at it and tell what it is in your position.
Yeah.
Yeah, that's pretty efficient.
I trust my software a little too much. I mean, it's burned me a few times here and there, but it hasn't been major enough to where I got to change what I'm doing yet.
Yeah.
But I do plan on throwing the tool setter back in there and maybe getting the probe up and running. We'll see.
Yeah.
Someday.
All right. Well.
So you guys I got a question. I didn't know you guys had a pallet pool on one of your machines or pallet changers. Is it one pallet changer? Just a.
Yeah, it's a two station Mitico. So it's like pallet A, pallet B. They just shuttle back and forth.
And you program that in your software? Are you able to throw in the pallet change in there, or is it all done at the control?
I hand edit that in. Yeah. Again, I probably could get them to do it, but which, of course, I don't know how it is on your horizontal, but it's pretty simple. It's just like M50 changes from pallet A to pallet B or vice versa.
Mine's M50 P1, 2, 3, 4, 5. Otherwise, if I'm using the schedule, I don't even have to put that in there. I just schedule it.
Oh, nice. So,
and then at the end of all the programs, I have to have an M99.
Okay, that's interesting. So. Yeah, we it's a little tricky the way I do it, just because well, we run the exact same program on each one, but the difference is the work ordinance. So like uh, pallet A might be G154 P1 and P2. Pallet B is P3 P4, just because they're not going to be identical, either just how they're set up or
Yep.
whatever. But it works really good. I mean, it was a huge improvement going from. I mean, we actually used that machine for probably, I don't know, 8 months, 9 months, not using the pallet changer, just because we really couldn't stop to set up and use it,
Yeah.
which was kind of silly. But I mean, sometimes you can't help it. Okay.
Yeah.
Next
question.
So I think I'm going to knock out two quick ones here. The first one kind of follows up on what we were just talking about. PDW 315 asked us about basically our recommendation on a cheap form of automation. So, quick little funny story that I thought of before we were recording from my friend Mark that I mentioned on the podcast before. He told me a story the other day. So when you think of automation, you probably think of like robots, bar feeders, stuff
Pallet
like that.
changers.
Yeah, pallet changers, things like that. But if you go back in time a little bit, I mean, automation goes all the way back to just a power feed. That's a form of automation. So he used to have a shop in Ohio. He had a lot of old equipment. And he told me a while back he had gotten a job that he had to put on a CNC mill. It was like forgive me, Mark, I probably got this wrong, but it was like let's say an 800-piece job. And it took 5 different tools. It was pretty simple. Well, his machine didn't have a tool changer on it. So guess what he had to do? He had to sit there, and the way that it worked out best for him was he ran all 800 parts through one tool.
Oof.
And then he swapped to the next tool, ran all 800 parts through that tool, swapped to the next tool, so on and so forth. And he got through it, and he was probably wore out when he got done. And he probably made pennies off of it, but I mean, he got the job done. So
Man, think about messing something up on like a depth on the second tool in that whole run, and you go through all those just to realize something isn't going to clean up.
I've ran a job like that way back when I ran an Easy Track. I started at a new company. They bought an Easy Track when I got there because they wanted me to run one, but they wouldn't buy the Weldon holders, the R8 Weldon one. So I was just using collets, and we had a job. It was like 20 parts, but I was like, do I swap out the collet each time, retouch it off? I was like, no, fuck this. I'm just gonna run tool 1 through 20 parts, and then I set up a stop, flipped it over, and then it was a pain in the ass, but
yeah,
it worked.
So like I said, we'll try to go through this quick. My biggest thing for automation is like a bar puller and a lathe is easy automation. You can run a whole bar, and it's best, teamed up with a parts catcher, but most of our lathes don't have them. We just stick a bucket in the machine and, just let it rip. I mean, tool changers on machines are a really handy form of automation. I mean, there's folks out there that don't have it.
Or they got an umbrella changer. I don't think I could run one of those.
I hate them things, man. A lot of our mills have them. I hate them.
Yeah, not a huge fan.
I actually saw something neat. Quick tip for folks that maybe don't have a tool changing machine. I forget where I saw it, but for like Tormachs and like mill drill conversions that don't have tool changers, this guy built like a rack. It was like a picture, like a piece of C channel, and it had a spot for all your tools to go in and sit in. And, it had just some kind of flange or something it could sit in and stay there. So when he needed to switch from one tool to another, he would just come over. I'm assuming the machine must have power draw bar. They'd come over to that spot, unclamp the tool, come over to the next tool. So I don't even know what you call that. I mean, it almost makes you think of a gang tool, but not really. So that might be something for folks to look at.
I was picturing that in my head whenever you were talking about Mark. running that
Yeah.
job.
Yeah.
Because
Yeah.
that's how our CMM is. Whenever it changes out probes,
Mm.
it has a tool rack, and it'll go over, come down, jam it into a channel or whatever, like a clip almost that holds it.
Yep.
Come up, come over, drop down on the next one, pull out, and then it's on its way.
Mm-hmm.
I think it's I saw it at IMTS. I think it was the track machines. They had it was considered a second op machine. I think Ian did a video on it. It was small, really small. I mean, it was probably only 2 feet wide, but the tools came out from the back under the spindle, and then the spindle would go down and pick it up and swap it out like you're talking.
Yeah.
It was pretty cool.
Yeah.
I've seen people do that for right angle heads as well. Keep it on the table.
Mm-hmm.
Okay. I've never used one of those in the CNC. That makes a lot of sense.
Yeah, I haven't either. I want to. I know Brad's used one.
Oh, I've used one
Mm-hmm.
once.
Remember that? Was that the only time you used it? That long ass
time.
drill?
How
long?
Wow.
I got it at an auction probably 3 years ago for like $50.
Oh,
I was like,
man.
oh, that's cheap.
Oh.
You know, I'll come across time, and it came.
Absolutely.
It-
I mean, I've used
I
one.
think I ended up drilling 20 inches from both sides on that thing.
Like 10 inches each side?
No, 20 each
geez.
side.
I wonder.
Oh, it must have been like 18 because it was
that-
36 inch.
That
part
was
I
a
had to go
small
through.
drill too. Small
Yeah,
diameter.
it was like a 5/16 or something.
How much-
See,
How much does that like? I would imagine at that length, it would droop a little bit on the end. Being
I
horizontal.
thought it would, but it didn't. So what I ended up doing was I drilled and reamed 3 inches in to start, just in hopes that drill would follow it.
Yeah.
I think it was actually 375 because the hole had a 375 plus or minus 5 call out, and I thought for sure when they met it would be off, but I ended up. So it was 36 inches hole all the way through the part. I was able to drop a 374 pin, and it dropped straight through.
wow.
And I just drilled it with it. Yeah,
Dang, man.
I had no idea what was going to happen, and
Yeah.
it worked out.
But now,
I think that was I got lucky.
if my comments on that video I put up last week of me using a long drill and a lathe, you should have just gun drilled it, man. Them things laying everywhere. Everybody's got one, apparently.
Yeah.
So I don't know why you didn't just do that.
Yeah. What?
You didn't know
Why don't
that?
you just go
knock on the neighbor's door?
Yeah. Just go
Right.
buy a gun drill for one part.
Oh man, I can't think of much else as far as like easy automation. But I mean,
The question I would ask is, what do you consider automation?
yeah.
You know, something as simple as standardizing tools in your machine. Like maybe I don't know if that would be considered automation or not, but sure is a hell of a lot more efficient.
Yeah. And what are you trying to accomplish?
Right.
What's the end goal?
Yeah. If you just want to free up either more time for yourself to do other tasks and something else can be running, then yeah, I mean, you need a way to let a machine be running for longer than one part of the time. And okay, so there's one right there. It's not so much a new form of automation, but an addition to what you've already got. If you got a CNC machine, don't run one part of the time. If you've got a 20 piece, 30 piece, 100 piece order, find a way to run 2 at a time or run 2-3 operations together in a way that, now that machine's going to run for an hour, I'm going to go do something else.
Mm-hmm.
Did we mention that on the last episode, fixtures? If you got a lot of parts to run, you can build a fixture.
Yeah.
Hold 20, 30 parts.
Yeah. That's always a good one.
If you can
No,
justify
I
it.
was thinking along the same lines as you, Pat. Like if you've got a part that takes 3 or 4 minutes per cycle, and you're like, damn, while you're sitting there running it, not doing anything else besides standing at the machine, you're thinking, damn, sure would be nice to have a robot right now to just load all these for me. Well, another option is, dual station vices, cram as many as you can on the table, or create some sort of fixturing using mighty bite clamps or something like that in order to hold a bunch of those parts. So you can run 20, 30, 40 at a time. Let the machine run for 2, 3, 4 hours while you go set up and run other jobs somewhere or program the next job. Either way, you're being productive outside of that. So that's a good one as well. Another one that I like to do is instead of running all of your operations, like all the parts on op 1 at one time, then all the parts on op 2 at one time, then op 3, whatever, do like single piece flow. So I've got op 1, op 2, op 3 all on the table all at one time.
Yeah.
So I get a finished part every single button press. So you end up going from raw stock to finished part every single time you press a button. So then that means they're coming out of the machine complete. If there's any last minute, deburring that you weren't able to get the machine, you can finish that up while you're running this entire job. And you can go ahead and, put it on a pallet or put it in a box, whatever, get it ready for inspection, all that stuff. Plus, you've got a good part after your first one is ran. So then the rest of the batch is going to be running good. So you can do a full inspection. Then you also gain cycle time that way. So like say you've got 10 minutes for your first stop. We'll call it 10 for each op, right? Now that's 30 minutes the machine is running versus 10 minutes where you have to come back, load the next part, but you're trying to do something because like that 10 minutes is a perfect window to go set up another job or work on something else. But then you end up taking 12 minutes, 13 minutes to get back to the machine.
Right.
So it sits idle for 2-3 minutes, dragging on the job. So yeah, now you got 30 minutes for the machine to run and you get a complete part out of it every single time. Like that's, in my opinion, that's one of the best things you can do for yourself if you're, well, I was going to say job shop, but even if you're doing production work, that's probably a really good one too.
Oh yeah, definitely. No, we on our the production parts we do. I mean, we have mighty black fixtures. We do it two different ways because again, we got two different machines. On the machine with the pallet changer, both pallets are set up the same. They've got one fixture for 4 parts on op 1 and 4 parts on op 2. Easy enough. You just get a finished part every time, and then when it changes pallets, it's running. And then outside the machine, you're changing parts out, getting ready for the next cycle. We run the exact same job on our VF1 that does not have a pallet changer. And the way that we handle that is we still use two of each fixture, but just at the end of the cycle, you open the doors. Well, little caveat. We swap out the op 1 fixture. It's already loaded with blanks. You just swap it out, put it against the stop, and there you go. It's ready. We have a really tight thickness tolerance on the op 2 side. So unfortunately, we really haven't been able to actually swap fixtures on it. So you do have to stop the machine to actually manually, take a drill and do the screws, blow it out, swap parts in the machine. But if you've got parts that aren't tight, they're not tricky on thickness and stuff like that, build 2 sets of fixtures so that you got some running, and then you got some that you're unloading and reloading outside the machine. That's a little more hands-on, but that's more a case of if you got an operator that's there, it's his machine, he's running it, you're going to get a lot more productivity that way.
Yep. Way better.
So,
yeah. And I don't know if that's technically considered automation or not, but it's definitely
kind of goes along with it.
Yeah.
Efficiency.
Yeah, definitely an efficiency improvement.
It's
you're kind of capitalizing on that machine time.
Right.
Making it as productive as possible.
It's actually a good way to, make more use of the automation you've already got.
Yeah.
So
low-hanging fruit.
That's a good word for it.
Get all those low-hanging fruit before you spend $50,000 on a robot.
Exactly.
Make yourself as efficient as possible, and then implement that expensive automation last.
The next little question that I had is from our friend Nub Tools. Metric.
Is this the one question?
The one question, yes. Metric versus Imperial, and why Imperial is better.
Well, it's obvious. We're in the U.S.
America.
Yeah.
I mean, you guys are going to kill me, but I kind of wish we did go metric. Sorry.
Yep. I'll say the same.
Really?
It's easier. I mean,
no.
I'm so used to standard that it's more difficult for me to use metric, but whenever I'm looking like metric drills and taps, I mean, that stuff's just simple, man.
Yeah. Yeah, that's a good example. Like when you got thread pitch instead of teeth threads per inch or whatever.
Right.
We don't do it as much anymore. We used to do a lot of work for metric, or I shouldn't say metric, international companies, Japanese or Australia or whatever. Yeah, the rest of the world.
Yeah.
So, I mean, I know pretty well just from memory. It's not like I'm smart or nothing, but you learn, okay, 25 millimeters is this, 24 is this, 30 is this, whatever.
I will say I'm sick of multiplying by 0.03937.
Why don't you divide by 25.4?
It's not as accurate.
I divide.
Well, I mean, sure, but like, how often do you need to go to the fourth or fifth decimal place, man?
I don't know. Tell you what, I need is a calculator with a little cheat code button. Just type in your metric number and hit a button.
There's
They probably got that on the machinist
Probably,
calculator.
That's what I was going to say. Yeah, the machinist calculator.
You just got to
Pros
use one of these.
I use the
This is
shitty
best calculator.
I use the shitty Windows calculator.
I do all the time too.
I do too. It's either that or my phone. We got calculators around the shop, but they're nothing special. They're just regular old.
I like the Windows calculator if I am trying to convert metric and I'm looking at something that's got a tolerance on there, because then I can see I can run them both and I can see them both
right
on the Windows calculator.
I'll show you guys what I use. It's pretty neat.
You know what sucks about that though? There's no history.
Yeah, I know.
Mine
more often than not, I'm using the standard like Windows calculator. Like
Brad. I typically try to use my phone. If I'm at the computer, then I'll kind of go back and forth between using my phone and the Windows calculator. If I'm not on the floor, I'm definitely using my phone. Mm-hmm. But like on here, it's the Samsung calculator. There's a little clock right there. If I just click that, it pulls up everything I've done recently. So
what do you mean there's no history on the Apple one?
Is there not? Is there one? I've messed around with it. I couldn't find it. Oh shit. Pat, do you get that?
I'm sure I do. I mean, iPhones are better than whatever junk you got.
At least they make mine obvious.
No, mine's just a little bar I hit at the top.
Actually, I don't see that.
Maybe I must have been with that new update you got.
Yeah.
Took them 7 years to add the history to the calculator.
You know what took me forever to figure out how to do is backspace.
Backspace?
Yeah, on the the old calculator. You know how you just swipe?
No.
Now the new one has an actual back button.
Yeah, no shit, because that makes sense.
Well, I got so used to swiping, and now I swipe.
So you had to do some magic bullshit that nobody knew existed in order to do backspace?
Yep.
Oh yeah.
Jeez.
Oh man. We got a calculation history on Apple Calculator before GTA 6.
I don't think GTA 6 is coming.
Probably not our lifetime.
Right.
So I actually had this discussion with a coworker the other day, which he's a good old boy. He knows inches and fractions and all that. It's just what you're used to. And if somehow overnight the U.S. switched to teaching primarily metrics, everybody would be used to it and it would be fine. The only problem is you have all this legacy equipment, vehicles, tools, everything, where it's in inches. And that's just hard to overcome. I don't know all the details of it, but as I've mentioned 1,000 times by now, our owner worked at Oak Ridge National Laboratory from, I think, the 60s until 1994. And he remembers how they were trying to make the switch to metrics. Because, it's Oak Ridge, you're in the scientific realm already. And so you're using a lot of, metric figures and stuff like that. So there was actually a push, and I don't know if maybe it was from Gerald Ford pushing towards metrics. Everything, metric machines, metric tooling, everything. Well, he has a story about how when Ronald Reagan was elected. I should not say it like that. And he basically tore all that away. He said, no, we're not doing the whole metric thing through this. They had to throw away so much stuff. I'm talking whole machines getting thrown in the dumpster because Ronald Reagan said so. Funny little side tangent of how wasteful our government is.
Yeah.
I know this has came up in our chat too. I've heard people say that metric is better because you can calculate the drill size easier.
Are you talking like for a tap, you use the thread pitch or subtract the thread pitch from the tap diameter? Does that actually work? I haven't even looked at
it. So it works for both. So like, say you got like a 3/16.
Yeah.
You would take the 375 and you'd minus the pitch 0.625 and it's
5/16.
312.
Mm-hmm.
I've always just memorized it. I've never even thought about the relationship.
Yeah. No,
Now,
that
same
works
with like your
perfectly.
832 or 1032. Your 1032, you take the 190 minus 032, and it's a 159.
Shit.
Mhm. Yep.
So, and a metric is the same. You just take whatever it is, M5 minus whatever, and then
Mhm.
that's your drill size.
Yeah.
It works both ways.
It's simpler. I mean,
But like you said, I
unless-
remember it, but my software does it all for me. I just select the damn tool
Right.
and it knows.
Yeah. So like we'll see an M10 by 1.5. So you'd end up at
8.5.
Yeah. Is that right?
Yeah.
I think I usually do 332.
I mean,
334, 332
Yeah.
Q. Yeah, I use a Q.
I
Yeah.
use an 8.5 millimeter drill. Thank you very much.
Wow. You have one?
Yeah. Oh, yeah. We stock metric
Who the hell
jobber
has that?
drills.
Actually, I think we have some of the. I've got some Go drills that are 8.5.
You know what drill would be nice if they made? Something in between the 128.5 and the 136.
Yes. Yes.
And not metric.
Yeah.
Oh, come on, man. Actually,
I always need like a 132, and I'm like, where the hell is a 132?
Yeah,
Well,
Come on.
you see, that's another argument against the standard system, right? You've got wire gauge sizes. I'm assuming that's what that's from. I've always heard of that. You've got letters, then you got fractions. It's like why the hell do we need 3 different fucking ways of identifying a
And
drill bit?
Why do we got 2/4 inches?
Right.
Yeah, E and a quarter. Yeah, it's so dumb.
Yeah.
And it's probably from 150 years ago, where the
I know
people
that's what
thought
happens. Yeah.
was standards were across the country or something. I mean,
Can't change it.
but
I mean, most of the time, I usually just search a tool vendor by decimal size.
Yeah.
mhm.
Which is kind of nice.
I will say, if you're for one, I'm noticing that a lot more tooling suppliers are starting like their solid carbide drills and stuff. They kind of seem to be erring more towards mainly metric stuff, or they might even list which I guess this would be your more European companies, but like they'll have an inch size, but they list it as the metric equivalent first.
Yeah. I know a lot of carbide drills are ground out of metric blanks.
Mm-hmm.
So it'll be like a 10 millimeter, 12 millimeter shank for whatever size drill. So like I figured that out, and I got them from Kennametal. They're collet nuts that have a seal that goes in the top of the collet nut. And so it's basically like a metal disc. It's got an O-ring on the outside and an O-ring on the inside. And it's a metric set. So pretty much all of our carbide drills that use through spindle coolant, they're all metric shanks. And so you just get that metric set, and you're going to have whatever you need for whatever size drill. And, you don't have to worry about stocking all the different size collets that are like sealed collets. You can just get that set, and you got it all, covers everything.
That is nice. That's one thing I don't like about some. I can't think of one off the top of my head, but I know there's some folks that make solid carbide drills, and they'll have like the same size shank. And I mean, I don't like that, because you can put it in collet, but it means you got to have, if you're doing through spindle, which we generally don't, but you'd have to have, so many sealed collets, and typically those are more expensive, especially when you get into like hydraulic chucks and stuff like that.
Yep.
I run standard ER16 collets with through spindle coolant.
Don't work as good, does it?
It's not terrible.
Yeah. The thing
I mean, as long as you're not spinning at 12,000 RPM.
Yeah.
Well, the ER16s aren't bad, but the ER32s are terrible. That'll just fan out.
What the main thing I worry about is with drills. You're not getting all that pressure to the tip to blast the chips out and keep it lubricated and everything.
That actually,
with end mills, I've done the same thing, but
it actually works really good though on a lathe if you're not using a through spindle tool, or I guess it'd be a through tool,
right.
It just blasts right down the slots in the collet, and it's probably about as good of a coolant as you can get on a lathe without having actual
like jetted collets. Yeah. The jetted collets are pretty nice. Those Eros holders, the Parlake Eros holders that we use, we have jetted collets for those, and they work pretty damn good. Even at like high RPM, you can get up like 10, 12,000 RPM, and it still doesn't fan out.
Wow.
Yeah.
I'll have to look at that, because I think we got some from maybe HPI, and like we which they were, I think the ones I made, they were members using, they were like ER16. If you got above like $2,000, they were just
Really.
useless.
That's kind of how the shrink fit holders are that I've gotten. When you get into
Yeah.
like 7,000-8,000 RPM, it just fans out.
Do they got the holes in
Yeah.
them? Just the two holes?
Yeah.
You got to. The Heimer's got the slots in them.
Yeah.
And them,
Oh.
I learned this that wasn't made for through spindle coolant. It's for the thermal process.
Really?
To make it easier. Yep.
Does it work
Oh.
good for the coolant?
Yeah, it works. It's awesome for coolant.
I'll be darned.
Better than the holes?
Oh yeah, I mentioned it to John Fetty once. I was gonna have him just wire cut mine.
Yeah.
Just wire cut me slots and all mine, and I made him a fixture for it. I've just never brought mine up there. He ended up wire cutting some of his, and he sent it down to Mari Tool, and they balanced it, and they were perfect. They were fine. So
That's awesome.
I was going to ask you guys what you got going on this upcoming week. Any jobs you're excited about, or anything you're going to get into that you're not looking forward to?
I'm excited for starting 410s.
Yeah.
So I've been working
410s are where it's
5/8s.
at, man.
Oh yeah, I mean, I've been working 5/8s for the past 10 years. Other than when I was working more than 5/8s. So, switching to 410s, having that extra day, especially when I'm in the middle of building it, thinking house or trying to, that's gonna help. So, we do have a really good job coming up. I touched on it at the beginning. Without getting too specific, we're fixing to start making some mounting bolts for like really heavy duty brush cutters. And you picture a bolt, you think like a half 13 something or other from Ace Hardware. No, this is like, it has to be 1/8", 12, I think, rolled threads, 1045, heat treated, certain range, certain way, and they've been testing these things for like 6 months. And we finally got to where, okay, these are good, make them, we're going to buy a ton of them. So we bought 14,000 pounds of steel to get started.
Nice. Do you have a roll form machine?
No, we bought a tool from LMT that just goes right in the lathe, and it'll roll it on there for you.
Like
it's really cool.
Would that be considered a thread whirler?
No, because I think thread whirling it cuts the thread, whereas these have to be rolled and formed.
Yeah,
and you don't have to have live tooling. I mean, it works like a static tool.
Yeah. Huh.
If you ever look into that, be sitting down when you find out the price.
Yeah. We've got some threaded rods that we make that they'll have like 1032 1.25 long, and they can't be roll formed. They have to be cut because the diameter of the rod needs to stay as big as possible. Basically, the diameter of the rod needs to be the major diameter of the thread. Mm-hmm. So you can't get pitch diameter rod and then roll form it. But as you can imagine, trying to turn 1032, 1.25, 1.5 long, isn't really going to happen unless you have, like a Swiss machine where it can retract in the collet and you can keep the cut supported right there at the collet. So I don't know. I would like to get like a used Swiss machine and throw it in the shop and just leave it set up for threaded rods, and then just have the programs all saved on there ready to go, and just adjust a macro or something for your thread length and press go.
I need to look. We had a guy worked here. He left a few months ago, and he was a programmer. He got into some other stuff. He told me one time about how he made some kind of crazy macro thing. He's really good at this, where he had a thin, skinny threaded piece that he had to thread, obviously, and he would thread like a part of it, and then I don't remember if he had bigger stock and he was turning it down in sections, like he'd turn a third of it, thread a third of it, and then come in and turn the next third of it, thread the next third of it. And he had some kind of macro to actually make it lead in and blend with the thread. Yeah. Or he might have been doing a bar pull thing where he was actually threading it, pulling it out a little bit, threading it, pulling it out a little bit. I'll have to.
I figure bar pulling would be. I don't know. Trying to blend threads like that with bar pulling seems like it'd be difficult.
Right. That
was it in a Swiss machine?
No, it would be in like a Haas SL20.
Regular lathe. I would imagine. Well, it kind of sounds like he would be turning the diameter down, so you can keep it kind of supported, keep your thicker material, and then turn that little section of thread, and then turn back a little bit more, and then it's supported from there, and whatever.
Yeah.
I don't know.
Yeah, I don't know, Ken. What about you, Brad?
I got some simple stuff next week. I do got a stainless angle 2 parts I got to run. A little too long for my machine, so it'll be interesting. You can do a shift. We'll see what happens.
It's always fun.
Probably won't hit the button and leave. I'll stick around and watch it.
Yeah.
Maybe a good idea.
There's a feature on it I didn't catch when I first looked at it, so I got to figure out how I'm gonna do that. It's got a slot going all the way down it, so I'll figure it out. It's only 2 parts.
Yeah,
brute force.
There
fixture.
you go. Nice. I've got my first attempt at vacuum fixturing coming up.
Oh yeah.
Got some parts. I'm going to op one of them and then flip them onto a vacuum fixture. And the vacuum fixture is more so just to pull the part flat. I mean, it's a big part, and it doesn't. You could probably get away with not using a vacuum fixture, but it's one of those things where I know for a fact if I do a vacuum fixture and it pulls this part down, everything's going to be good, and I can run all 12 of them without issue, hopefully.
Yep.
But I'll be combining the vacuum fixturing with locating from expansion clamps. So like Mighty Bite makes them, a bunch of people make them, like where it's just a bolt in the center and it expands out like the opposite direction of a collet.
Yep.
So this part has 4 through holes, but I'm going to machine them accurately so I can use them for locating, and then drop the part onto this fixture, tighten up all those expansion clamps, use that to locate it. Actually, no, I guess I can't do that. I'll need to vacuum it first. I don't know. We'll see what the hell happens. I don't know. And then I'll test it out, and I may end up just probing each one from there just to guarantee that I'm concentric, because there's a lot of...
I've built in bosses in my vacuum fixture to locate parts.
Well,
and then just
run
something around them.
It's a steel part. It's a big part, and I need more holding power than just vacuum. So I'm kind of using the vacuum to pull the part down flat. And just to kind of guarantee, like, because you get like 1 chip underneath there or something without the vacuum, and you're just using those expansion clamps, part's dead, part's toast. So I know I think it was like 2,200 pounds or something that it calculated of holding force from the vacuum, or whatever, like force pulling down from the vacuum. I don't have experience with vacuum, but I would assume, like, if you've got a small chip in there with a steel part and an aluminum vacuum plate, it's going to imprint it into the vacuum plate, which is what I want. So I want that part to be flat every time. Screw the plate. I don't care if the plate gets messed up. I'll make another one if I have to. But then really use the expansion clamps to hold the part. And I don't know, see what happens from there.
Yeah, I mean, them vacuums got a lot of force. They hold pretty well. I've ran some face mills, 1/4 inch depth to cut across a 60-61 plate, 100 inches a minute.
See, I've never talked to anybody that's ran steel on vacuums, and I've asked.
Yeah, I'm curious.
Yeah, anybody that I've talked to that's has vacuum experience, they haven't ran steel. So if somebody knows, if they've ran steel and they know you can do it, tell me, because that's basically all we run. And if I can do more vacuum stuff on steel, then cool. I mean, I know I can regardless. Like, you just cut light enough and you're good. Yeah, but I don't want to be making like...
I mean, it's going to vacuum. It's going to suck it down. Right. It shouldn't make a difference. It's just...
I feel like you're going to have... If you try to... I don't know.
Sure.
I think you can definitely remove material faster on aluminum on a vacuum than you can with steel. And if you machine steel light enough to not push it off the vacuum, how light do you have to machine it? Are you talking, 20,000 step over and, feeding it super light to keep something from happening? I would imagine you could get more out of it than that. But then also, if you're doing like 1 1/4 depth of cut, all that force pulling up on it, I don't know.
I think you should be good. I mean, when I started getting into vacuum, I was programming slower because I was nervous.
Yeah.
And now I program it no different.
Really?
I probably actually program it faster and I push them harder.
Yeah.
And that thing doesn't move.
Yeah.
So, I guess if you can fixture it in a way where the part can't shift, the vacuum's going to hold it down unless it moves. If it moves and breaks the gasket, you're screwed.
Right.
Yep.
But if you can do like expansion collects, your mandrels,
whatever.
Yeah, pocket, a boss.
I have on a lot of parts on a second op. I don't know your first op if you're profiling on anything, but I have flipped parts over and I've pocketed it down
Right.
so it locates,
Mhm.
a quarter inch down, and then
well-
vacuum it down and it doesn't move.
Yeah, so we received these parts rough turned, and they have like a big
Ah.
square flange. So like there's bosses on the front and back side, and the thing's like 18 inches square, and then it's like I don't know 2 or 2.5 inches thick or something on that flange, and so I don't want to blend the flange. We don't have a chuck big enough to hold from the boss on the what will be the op 2 side. So what I want to do is just use some of those octane clamps and clamp it from the side on op 1. Do that whole side. Don't worry about the profile. I'll machine deep enough around the outside just to put a chamfer on it. So when I flip it and machine the profile, the chamfer's already there. But yeah, then flip it onto the vacuum fixture, expansion clamps, that whole shebang.
Yep.
Okay.
And then profile it then anyways, all at one time. But anyway, pocket won't
Well,
work.
if you need any advice on the vacuum, you want to send me something, let me
All
know.
right. I've already got the fixture designed. So maybe I'll send it to you and see what you think. I was thinking about doing O-rings around a lot of the through holes, but I don't really know how well that's going to go. I was talking to one guy. He said they use O-rings from McMaster that are like 50 diameter, and they work just fine, like 16th O-rings. So going off of his advice, that's what I have designed in there right now. But
yeah. The only thing I've noticed sometimes with O-rings, and if you're using neoprene on the outside, you just got to make sure your depths of your O-ring are the same, so it's compressing. But with steel that heavy, you're not gonna.
That's one thing I was worried about. I was thinking about doing the O-rings deeper than what they recommend for neoprene, just so like there's enough there to where it'll seal, but not enough to where the O-ring doesn't have anywhere to go because it's still an O-ring. It's not the neoprene, like the actual gasket material. So
I do like the soft Buna cord that I'm running now better than neoprene, because the neoprene, after some time, that coolant gets into it and absorbs and it starts shrinking, or you rip it.
Right.
But the Buna cord that I use, it's a little bit harder. I do have to do a deeper O-ring groove.
Yeah.
But I think it holds a lot
use
better.
an 1/8 inch? How deep do you go?
120.
Okay. Cool.
So
Oh, wow.
that Buna cord that I have, it doesn't compress very well. And then I think I don't know what Pearson recommends for width. I think it's like 118 maybe. I usually go a little bit wider too, just so that cord will compress. Because if it's tight in there, it has nowhere to go.
Yeah.
Mhm.
Cool.
So
Well, I guess it's about time to wrap that up. Don't forget to go on Spotify, Apple Play, or what was it, Apple Podcasts, YouTube, wherever you listen.
YouTube.
Yeah. Comment, like,
And
subscribe.
Guy, come comment. Let us know about them robots.
Yeah.
If you think
Yeah.
favorite programs.
Yeah.
Or,
And then on the forum as well. Tell us how right or wrong we are.
Tell me to buy a gun drill.
Yep. All right. Awesome. Well, good talking to you guys. We'll
Yeah.
you
catch
too.
you later.
You too, bud. See
Bye.
y'all.